Hello students, myself Mohammad Ashraf, Department of Physics, Seekers Educational Services. Today we are going to talk about capacitors. Basically, what is a capacitor? What does it do? Okay, what are its implications? So basically, as you can see, as I have mentioned here, usually capacitor is what? It's a system of two conductors having equal and opposite charge. So if we have two conductors and both the conductors are carrying equal and opposite charges, that will be called a capacitors. Okay, and we know that if we have two conductors and both of them carrying some charges plus and minus, there will be some electric field in between them. Okay, that electric field will be in between them. It will hold some energy. That energy is called electrical energy. Okay, as you can see, it's made up of two plates, positive plate and negative plate, holding some energy in between them. That is a capacitor. Moving forward, capacitance of a capacitor. What is the capacitance of a capacitor? Okay, charge per unit potential difference. As you can see here, C is equals to Q. As I have mentioned also, one of the definitions of capacitance. Capacitance of a capacitor is defined as the ratio of magnitude of charge on the plates of the capacitor and the potential difference across the plate of the capacitor. How much charge it can hold with respect to per unit potential difference. So as you can see here, capacitance is written as Q is equals to V, where Q is the charge on the capacitors and V is the potential difference between the plates of the capacitor. Now if you see here, total overall charge on the capacitor is 0, because if one plate consists of plus Q of charges, another contains minus Q charge, negative charge. So if you see the overall charge, plus Q and minus Q will become 0. So overall charge on the capacitor is 0. So it does not mean that this Q will be 0. This Q is basically the positive charge on the one of the plates of the capacitor. Okay, this is not the net charge. This is not net charge. This is the charge on the positive plate of the capacitor. C is equals to Q by V. Parallel plate capacitor. What is a parallel? Now we have a different types of capacitor. For example, parallel plate capacitor, spherical capacitor, cylindrical capacitor. Okay, so as the name suggests, the plates of the capacitor must be parallel to each other. So as you can see here, I have drawn in the PPT also. We have two plates. One is plus, another is minus. Okay, connected with a battery source. As we connect with a battery source, okay, one of the plate becomes positive, higher terminal, another plate becomes negative terminal. So there is a potential difference developed in between them. Okay, that will generate some charge. What is the capacitance of a parallel plate capacitor? Capacitance will be equal to epsilon naught A by D. Okay, epsilon naught is a constant permittivity of vacuum or permittivity of free space. A is the area of the plate and D is the distance between the two plates. Got it? Now if you see here I have tried to calculate the electric field between the two plates. As we know, electric field because of a plate is sigma by 2 epsilon naught and because of another plate is also sigma by 2 epsilon naught. So overall it becomes sigma by, sorry if it's wrong here actually, sigma by epsilon naught. Sigma by 2 epsilon naught plus sigma by 2 epsilon naught is equals to sigma by epsilon naught. This is the net overall electric field in between the plates of the capacitor. Next one is capacitance of a spherical conductor. If you have a spherical conductor, what will be its capacitance? So for example, if you have a spherical conductor, as you can see here, okay, on which plus Q charge is distributed. We have a sphere on which plus Q charge is distributed, radius is R, charge is Q. Okay, so we know that potential of this conductor will be how much? Potential will be 1 by 4 pi epsilon naught Q by R, and C is what? Q by V. So if we calculate Q by V, it becomes C is equals to 4 pi epsilon naught into R. So this is the capacitance of a isolated spherical conductor, 4 pi epsilon naught R. Remember this formula, very important. Next one, spherical capacitor. How a spherical capacitor is made? It is made up of two spherical shells like this. This is the first one and this is the second one. Okay, one of them is given a positive Q charge and another is given a minus Q charge. Okay, so there is a potential difference developed in between them, which is here 1 by 4 pi epsilon naught Q into B minus A by B. What is B and what is A? B is the radius of bigger sphere. Similarly, A is the radius of smaller sphere. Okay, as we calculate the capacitance, which is equals to Q by V, when we take the ratio, it becomes 4 pi epsilon naught AB divided by B minus A. 4 pi epsilon, again a constant. A is the radius of the smaller sphere and B is the radius of the bigger sphere. Moving forward, capacitance of a cylindrical capacitor. Okay, capacitance of a cylindrical capacitor means if we have two cylinders, okay, coaxially, as you can see here, we have two cylinders coaxially. What will be the total capacitance? So again, it will have two radius. The smaller radius is suppose A, the bigger radius is suppose B. Length of the cylinder is suppose L. Okay. So if one of them is given a positive charge, another is negative charge, okay, an electric field will develop in between them. Because of electric field, there will be a potential difference in between them, okay, and if there is a potential difference and there is a charge there, okay, we can find the capacitance. So the capacitance for a cylindrical capacitance will be C will be equal to 2 pi epsilon naught L ln of B by A. B is the bigger radius, A is the smaller radius, L is the length of the cylinder. Field due to a charge on plate on the other is sigma by 2 epsilon naught, hence the force is QE. So now we have to find the force between the parallel plate capacitor. Of course, there will be some force in between the plates of the capacitor. Why? Because one of them is positive charge, another is negative charge. Okay, just now we calculated electric field, how much? Sigma by 2 epsilon naught. Sigma is what? Surface charge density. We can also write it Q by area. So it becomes Q by 2A into epsilon naught. Got it? Charge on one of them is how much? Q. So if you multiply Q, it will become how much? Q square by 2A epsilon naught. Q square by 2A epsilon naught. This is the force between the plates of a parallel plate capacitor. Just remember the formula, Q square by 2A epsilon naught, where Q is the charge of the capacitor, A is the area of the plate. Epsilon naught is a constant. Moving forward, energy is stored in a capacitor. Energy is stored in a capacitor. Okay, so we know that if we have two if we have a capacitor having one plate is positive charge, another is negative charge. Okay, there will be an electric field inside them. Because of the electric field, there will be an electric field energy associated with them. Okay, so we will have a electric field energy. Just like in an inductor, we have a magnetic field inside the inductor. There we get a magnetic field energy. Okay, energy associated with the electrical field is called electrical field energy. Okay, let's see how much. So it's not given here. So basically, electric field energy, if you calculate the potential, it comes half CV square. This is the energy stored in between the plates of the capacitor, half CV square. Moving forward, combination of capacitors. Okay, how we can add two or more capacitors. The first one is, as you can see, series combination. As you can see, this is the first capacitor C1, C2, C3. Okay, they are connected in series. Okay, what will be the equivalent capacitance? The equivalent capacitance will be 1 by C equivalent is equals to 1 by C1 plus 1 by C2 plus 1 by C3 plus whatever be the number of capacitors. This is the combination formula for series combination. Next one, parallel combination. As you can see, these two are connected in parallel. So formula for a parallel combination will be C equivalent will be equal to C1 plus C2 plus C3 plus C4 plus up to Cn, whatever be the number of capacitors in the system. Moving forward. Yeah, okay, that's the end of these slides. Thank you so much.